Hello guys, welcome to another grand interesting video on your Be Aware channel, and we are going to today take a look at how to create a logic for part diversion to respective areas. Okay, so basically the problem statement for our today's modeling would be that we are creating part from one area, and we need to transfer these parts to our respective queues based on the logic as per requirement, right? So we are going to have a certain logic which is going to be in place, and based on that we are supposed to transfer these parts to the respective queues. Okay, and this is the conveyor system you have. Okay, and you see on this right side we have a process flow. Again, we'll understand in detail why we have created that and how the logics are supposed to be utilized, right? But this is how the model will be looking like, and how is it going to be visualized. So this is how the part are going to be transferred, right, from the conveyor to the different respective queues and to the jackpots. This is what we are going to learn in this today's video. So stay tuned with us till the end of this video, and you will be able to learn about how to create such a type of logic in Flexsim simulation modeling. Okay, so let us understand in detail about the problem statement first. I'm just stopping this model. Okay, so if you haven't liked the video, please guys do like this video, comment your doubts if you want, and do not forget to subscribe to our channel. Be aware where we brought educational content has been brought onto this channel which can help you groom yourself and upskill. We have a lot of exciting educational content on our website as well as on our YouTube channel. Okay, so if you see this is the conveyorized system. So let us talk about the logic. Now when the part comes in, what is supposed to be checked is we need to check out that amongst these 6 queues, there is a first criteria which has to be checked in, as that is that the queue should have a maximum capacity of 10 parts. Okay, and you see this is the counter label. We have already set it up on every queue, which is going to make a count of how many parts are available on my queue. Again, the challenge for such type of logics is that the parts when arrive on this arrival, this decision point of the conveyor, it has to decide whether it has to go there or not, and therefore we need to check the available spaces available on these queues at this decision point itself. So we have to do all our checks here itself. Okay, because what might happen is there are already 3 parts which are going to go and enter in this queue, but currently we might be able to see that the capacity is only 7, but these 3 parts are going to make this queue 10, and therefore our 4th part should also not go in here. So we need to have all of the checks done here. So before we begin, the first thing which we need to test is that that we need to have a counter label which is available on each of the queue, which is going to take account of our first criteria, that is the parts available in this queue should not be more than 10. Okay, now if you see in parameters, we have this already listed. So if you change this value, it is highly dynamic. When you talk about this next thing is empty per part, which is 30 seconds. So the next time is what is like we have 10 parts in this buffer, but every one part is out from this buffer every 30 seconds. That is another logic. But when we empty these queues in a lot of say 10, and when the quantity becomes 40, this is another criteria that whenever our quantity, that is when our 40 parts are leaving this queue, what we need to do is we need to have a pallet change time enabled, and that is for 100 minutes. So we have 2 criteria. One is that the current capacity should not be more than 10 parts. Second, the out from the queue, when it is going to be 40, we need to initiate a pallet change cycle time, that is whatever that is for. We will be entering here, so 100 seconds we are going to have this queue in functional. So if such type of logic you want to create, so the solution is what we are going to give you today in this video. So what I'm going to do is now, I'm just going to reset this model and let us analyze what this one first. So what we had is, if we look at what we're going to have is that we need to have one part out from these queues every 30 seconds, which we saw here. So we have a process flow created here, which we say that on entry to this queue, we are going to have one token, right? And when we have a token, we are going to check that whether, we are going to have a pallet change going on or nothing. We have another delay of empty per part, which is already assigned here, so that the part is synchronized for in and out of this. So we have a delay here, which is equal to 30 seconds. So if we are not going to have this pallet change logic in equal to 0, it is going to be like delayed. But if we don't have any pallet change logic enabled, that is our third label, that was the 40 parts are done, we are going to initiate pallet change, and this is going to be 1, not 0. So if it is 0, then we are going to straight away go down. We are applying a delay of 30 seconds, which is from the model parameter, and we are going to run a subflow. Subflow is currently used for one part. If you have a batching of some parts, like I remove 10 parts every 30 seconds, you can change the quantity here. But currently I remove only one part every 30 seconds. So what I say is that I have to move my item from this queue to this thing, and then what I do also is that I reduce the counter by -1, because we need also to take a track of that. I had 10 parts, but my one part has already been gone by processing of 30 seconds, so I have a capacity of one more part, so it becomes 9 now. And therefore we have mentioned in the custom code that we need to have this subtracted. So if you see, this top code is in order to move one by one part at a rate of 30 seconds, which is our logic, and then it is also going to subtract the parts out from this so that we know the actual capacity of the queue, right? And then we have the next logic, which tells that whenever our 40 count is done, we are supposed to initiate a pallet change, and when the pallet change is going on, no part should go inside. So the major code of that also is included in this decision point, and we will now be understanding that how the code has been taken place. Now when you look at this, what we do first is we are checking a if loop, and the item.port is nothing but we are going to have a label on the item, right? So if you look at this, on entry itself, I am assigning the names of the queues which is going to have. So it is having a primary destination, it is having a secondary destination. So this is how I'm going to have. So I'm going to have two types of label on the part. So let me just run and show you. I'll just stop it. When I click on this part, if you see, I have two queues as labeled on that. So I have a details of destination. First destination is Q4, second destination is Q7. If you don't have Q4, you go to Q7. That is what these labels are supposed to be. Now what I'm going to check is, I'm going to find out that the counter of my queue, is lesser than what is required. If it is less than 10, I'm just going to go inside, right? And then what I'm going to do is, I am going to find out the number of, so if you see, what I've also done is, this decision point has an output connection, but it has an output connection to all these queues, but basically from this exit transfer. So basically, this decision point is first connected to these exit transfer, and from these exit transfers, these are connected to this queue because we need to tell the part or item that which area you need to go. So that's the reason what we have done is, this is the code in order to identify that how many outputs are connected to this decision point. Now we have our outputs connected to this decision. So we find it out that, say, for example, I'm having 7 outputs. So the J would be 7. Now what I'm going to do is I'm having another for loop, which is going to run from 1 to 7, because 7 was my output length total ports. So I'm going to check now each of the port one by one, and that is where we use for loop. And then when we go in here, what we are going to do is we are going to get a name of the queue How we are going to get it? We are going to find out that my output of the decision point is my exit transfer. Then the output of my exit transfer is reach queue. So this is that. So this is a dynamic parameter. If you see every output, that is every exit transfer. Out of exit transfer, we have only one connection connected to the queue, so there is no issue. So that's the reason I've kept it as 1, flat 1. But if you see here, my every port has to be checked. So what I do is every port I check that this is my queue, this is my queue, this is my queue. Why? Because at the bottom I go and validate that the queue which is available as a label on my item, is it the same queue with my I? So here it is. So I get one queue name from here. This is my another queue name at the item port, right? So for example, if this is the first thing is Q4. So if you look at my Q4 is here, right? So Q4 is here, and when I look at the exit transfer, it is 3, and here if I see it is 3. So basically my my I has to be 3. Then only this code is going to get executed, because that time my Q4, which I would be getting from this code, will be equal to this one. That is, my queue will be equal to my label, and then I will go inside. So I hope you would have understood till this. If you have any queries, reach us out from our website or from our Gmail mentioned in the description, right? Now what we're going to do, we are just going in down, and we are finding out that if my label and the queue matches, I'm going to check whether part is available on the queue, right? And whether my counter has a value. So if everything is 0, this is the initial case, I'm going to set my counter to 0. Okay, and then we go in this. This is a real crux of the story. What I see is, okay, I have my queue. I got a queue which is equal to my label. Now I'm going to check whether my counter is less than the maximum capacity, which is, if it is less than 10, okay, I'm ready to go there. I'm going to then tell him that I need to send this item, the item to the new destination, and the new destination is the current output, that is 3, because I is 3. When my queue is equal to item port, my I is going to be 3, and that's where I'm going to get my output port from where I need to go. Here we are sending my item, here what I'm going to do is, here I'm incrementing my counter. So I have already forwarded my one part towards this queue, so I will say that my counter from 0 will be incremented to 1. Similarly here for pallet counter, as we need to track of 40 parts, once 40 are done, we are supposed to initiate a pallet change, that is for here. So we are incrementing here. Now what? If my pallet counter is equal to pallet quantity, that is, I have output of 40 parts, which is equal to what was required in the logic, I'm going to initiate a pallet change from 0 to 1. So my label will now be 0 to 1. Now if you see, my label will be changing for this pallet change from 0 to 1 when it is required. And then what I'm going to do is, now if pallet change is 1, what I'm going to do is I'm going to make the pallet change to 2, because now I'm going to start a pallet change logic. So that is the reason I have made it 2, to clearly understand the difference. So 0 is no pallet change, 1 is that we need a pallet change, and 2 is that we are going to start a pallet change. We are sending a message. To send a message, we need to have used this code. Now what this code states is that I'm going to send a message to my, basically I'm going to send a message to the object, that is the queue, okay, from the current object, that is my decision point, and the message parameter is 1. So here I'm telling that I'm sending a message from this decision point to the queue with message parameter 1. So if you see in the process flow now, which I just stated earlier at the start of this video, here we are going to make this that if I'm going to get a message from a queue where I am having a value of 1, which I showed you here, which we are matching out here, I'm going to get a token generated here. And this token will now be, having a delay of how much? That is 100 seconds, which is available here. And if you could see, we have already mentioned, in the codes up there that we need to have pallet change as 0. And that is where we are not going to have these parts. So basically we are going to send these parts in when my pallet change is started, I am not going to have my parts out from this system. And that is where we are controlling here. When my pallet change is 0, then only I am going to send my parts out from the queue. If the pallet change logic is initiated, that is, it is here, I am not going to send any part out from the queue. And once my pallet change is initiated, I will come here, I will make my pallet change to 0 again. Pallet counter to 0 from 40, we'll make it 0 so that we are ready for a new fresh run. And similarly, we have made it for the same code is copy pasted below, that if my primary locations, that is I showed you, right, port is not available, I will check for port 1, which is my next locations. These are my bottom queues. If my bottom queues are available now, I am going to send my parts to the bottom queues rather than the top queues, because top queues might be in a pallet change, might be that they have a 10 capacity already reached. That is where you see that our parts, just go into the bottom area, and this is how it goes, right? So whenever we have a pallet change going on at the top, you see this? These go to 10 and the parts are then diverted to below. Now another thing also what we have done is, if my primary as well as the secondary locations are full, I am supposed to send to the third location, and that is, you can say, an infinite loop or a queuing loop where you send those parts, and whenever my primary and secondary are available, these will come back again and will be feeded out. So this is a whole Flexscript. By the way, we write it in the Flexsim in order to execute certain logics required. So if you could have seen, this simulation model has been made with what we can say, a combination of conventional method and a process flow, and that is how major of our logics are being created in a Flexsim. It's a very great, what we can say, a combination of creating flexible logics. It's really pretty enough. And hope you would have liked this video where we have explained how to divert parts based on the requirements of certain logics, how we are going to use the parameters, how we are going to use the process flows, what are the entities in the process flows code, and how is this process flow triggered from the conventional Flexscript. Hope you would have liked this video. If you have any queries, you can reach us out through our website behaviorchannel.com, and you can book an appointment for reaching us out, and we are there to help you out. Any support required in industrial engineering related stuffs, simulation projects, might be industrial, might be your students, right? Any training required on this part, let us connect together, and it's going to be a fantastic journey. Thanks for staying with us till the end of this video. Let us meet in another grand interesting video on your only behavior channel. Till then, stay safe, stay simulating. So welcome to our website behaviorchannel.com, and you can see that we have a lot of educational content just for you. So the specialized content we have is discrete event simulation support, then we provide you industrial engineering training, then we have lectures for you, and then we have blogs which are literally going to groom your skill sets and your knowledge. Then we have a very important aspect of our life, that is health awareness related stuffs on your behavior channel. Okay, so here is our booking online appointment tab. So in the home you will get the tab where you can book online appointments for if you want the Flexsim simulation training, you can book it here. If you want the support related to simulation projects, that might be industrial simulation projects, then you can book and take an appointment from here. We will be discussing on that into this. Then if you want a support related to creation of 3ds model files which you can import in your simulation for better visualization, we have that in here. You can book the appointments from here. If there are any simulation project support for engineering students for their educational purpose, for their educational projects, if they need support on, then we are there to support you. You can book your appointment from here, and we can have a thorough detailed discussions, and then we can take ahead the plan of how it has to be done. Then if you want the customized simulation model for your industry simulation projects, for your engineering projects, we can provide you customized simulation modules. So to know this in detail, book appointments now. There are very limited slots available, and it's the fastest thing you need to do is book online appointments.